We live in the age of great astronomical achievements. Over 5,000 distant worlds are known to us thanks to today's orbital telescopes. Most of those places are truly wonderful places, unique and mysterious, and sometimes extremely dangerous. There are planets out there illuminated by 2 or 3 stars at the same time, whereas others are eternally shrouded in the darkness of space. Some of these worlds inspire terror by their extreme conditions, while others make one marvel at their bizarre features. We have already been on a journey to the most horrifying planets before. It's time to move on to other objects. As a rule, it's potentially habitable planets with favorable conditions and a moderate climate that especially catch one's attention among the great diversity of other worlds out there, or else, on the contrary, extremely dangerous objects stand out among others. Still, there is yet a third category. It's anomalous celestial objects manifesting unusual behavior which is barely scientifically accountable. Objects like that challenge our knowledge and deserve special attention. This is exactly the kind of world we'll be looking at now. 2009. The environs of the Kepler 413 system. An unknown object passes between our planet and the distant star, briefly reducing its luminosity. Astronomers take this event to be a standard exoplanet transit and announce the discovery of a new celestial body. However, 180 days later, another expected transit never occurred. High-precision calculations even make it possible to determine its parameters. The planet turns out to be a cool giant with a mass of about 25 times that of the Earth and a radius of about 40% that of Jupiter. The planet, so clearly visible in the old data, seemed to have vanished without a trace. A dark spot in the photosphere of the star, or a giant dust cloud moving in its vicinity, would have accounted for the mysterious phenomenon. But these hypotheses were dispelled when 800 days later the mysterious object reappeared, just as suddenly as it had vanished. The hypothetical planet eclipsed the disk of its parent star 5 times before disappearing again. Still, the key to the riddle had been found. It turned out that Kepler 413 bits has a highly unusual orbit. The celestial body is located near a binary star and is 0.36 AU from the system's common mass center. Its trajectory is constantly affected by gravitational perturbations, and the changing gravitation of 2 nearby stars shifts the orbital plane considerably, causing cyclic oscillations. When the deviation reaches its maximum, the object leaves the line of vision and then returns to it. Calculations show that Kepler 413 bits orbit oscillates with a periodicity of about 11 years, deviating 2.5 degrees in each direction from its average value. The planet's own axis of rotation also changes its position significantly, with a maximum angle of inclination of up to 30 degrees. Combined with the noticeable eccentricity of the orbit and its periodic shift, the climatic conditions on the surface change in a bizarre way. The region that receives the most light from the parent star is constantly shifting from the equator to the poles and back, which leads to dramatic variations in temperature. It is likely that this process generates huge planetary-scale hurricanes, which can be larger than the Great Red Spot of Jupiter. Air currents can carry ice clouds at several kilometers per second, gradually becoming unstable and dispersing. Meanwhile, the collision and deformation of vortices is capable of causing tremendous atmospheric emissions that have the power to overcome the planet's gravity and reach outer space. According to calculations, they will hang a while up there before gravitational forces pull them back down. All these incredible phenomena make the planet a rather harsh place. However, it may seem like a tranquil, serene island in comparison to the following world. 190 light-years from Earth. The environs of the HD 8606 system. This yellow dwarf, surprisingly similar in parameters to the Sun, is orbited by a planet with a highly variable climate. It whizzes towards its parent star as rapidly as a giant comet, burning itself in the hot rays of its corona, only to drift away to the periphery of the system. The object in focus is a gas giant with a mass 4 times that of Jupiter, in an elliptical orbit around its parent star. Its furthest point is similar to Earth's distance from the Sun, possibly allowing for cloud condensation in its atmosphere. However, as the planet nears its star, conditions drastically change within 55 days. The energy influx from the star surges, causing rapid temperature hikes and triggering violent hurricanes. Its atmosphere expands enormously due to substantial heat absorption, leading to shock waves that sweep across the planet. Water vapor decomposes, and quartz crystals are temporarily turned to sand clouds. The planet, likely the only one in its system, has a destabilized orbit due to a nearby star's gravity, which may have disrupted the protoplanetary disk. Similar scenarios are common in celestial interactions. The system is located 1,530 light-years away from Earth, centered around a yellow subgiant, similar in size to our Sun. Two planets, a rocky super-Earth and a hot mini-Neptune, orbit their star closely, meeting at a critical distance every 97 days, causing cataclysms due to their intense gravitational interaction. With a gravitational pull 13 times that of Earth and the Moon, the rocky planet experiences seismic activity and potentially consistent magma seas. The super-Earth, Kepler 36b, is speculated to be a Chthonian planet, a gas giant core that lost its atmosphere. It orbits its star every 14 days, has a mass 3.8 times Earth's, and a temperature of over 700 degrees Celsius. Kepler 36c, a hot mini-Neptune, orbits every 16 days with a mass 7 times Earth's. It possesses a thick, multi-layered atmosphere and a supercritical fluid ocean surrounding its core, suggesting potential for fantastic phenomena. The gravity of larger planets can seize satellites from smaller ones, forming vast asteroid streams due to tidal forces. Additionally, the mutual gravitational forces of two planets distort their orbits and behave unpredictably, with a 91% chance of collision in the next 70 million years. This collision could scatter thousands of debris pieces, increasing the system's chaos. A curious object dubbed Super Saturn and located 434 light-years from Earth echoes this chaos. It's a young, still-forming large gas giant or brown dwarf, 20 times heavier than Jupiter, with most of its atmosphere composed of hydrogen and helium. It showcases a ring system larger than Saturn's, with at least 37 distinct rings detected. The circumplanetary disk is larger than Venus' orbit, and 640 times larger than Saturn's rings, with a mass greater than Earth's. It's an unstable and random structure, gradually losing parts either by falling into the central planet or escaping the disk. This process could take several 100 million years. An identified large rupture, possibly caused by an exosatellite that is 80% the mass of the Earth, suggests the potential presence of other substantial celestial bodies and predicts hundreds more that could exist in the central object's gravitational field. Simulations including various planetary factors show the temperature of these bodies could be habitable. From an exosatellite's surface, the brown dwarf in the night sky would loom 70 times larger than the full moon, bathing everything in a twilight glow. The sky would be lit end to end, the landscape would be marked by eruptions and vast tidal waves due to the dwarf's gravitational pull, creating a new kind of climate, a blend of land and ocean floor. However, these features are unstable, changing rapidly. The fate of the enormous rings and their appearance in the future is uncertain. Our understanding is continually evolving, as deep space uncovers more mysteries, fueling human curiosity and endless learning. Your engagement helps explore more about space and distant worlds. Let's stay connected.